First, we poke a hole through the two bottle caps and fill one of the bottles with water. Cap the two bottles together and flip the bottles. As we can see, the water is not flowing down from the hole we created. This is because there is an upward force in the empty bottle that is equal to pressure of air times area, and the downward force, which is hydrostatic pressure, which equals to density times gravitational acceleration and height times area. These forces are in equilibrium, which explains why water is not flowing down. Next, we twirl the bottle to create a vortex. This creates a channel for the air in the empty bottle to escape upwards and for water to flow downwards. Continuing from the previous experiment, when the water is in equilibrium, we poke a hole in the top bottle and water starts flowing at a faster rate. This is because the force acting downwards is now hydrostatic pressure times area plus atmospheric pressure. Since the downward force is greater than upward force, the water will flow downwards.
This experiment focuses on the viscosity of different liquids and how it flows. The more viscous a liquid is, the more sticky it is, which makes it harder to flow. As shown in the video, when water is mixed with oil, it flows less smoothly than the initial water-only experiment. Since the oil is more viscous and less dense than water, the water will have a much easier time flowing downwards compared to the oil, which mostly stays at the top. In this next experiment, we are going to observe how the viscosity of fluids affect the flow of water. We will be using oil, which has a higher viscosity than water. First, we colored our oil with blue dye and poured it into a bottle filled with water. Next, we capped the two and flipped the setup over. Immediately, oil, which has a lower density than water, flows to the top surface of the mixture. Again, we twirl the bottle to create a vortex. Water and dye, which have the same viscosity, will mix together and flow down smoothly as shown here, while the more viscous fluid, oil, remains in the top of the bottle.